Okay, we are going to talk about how to solve a system of equations, which is just more than one equation and more than one variable. That would be a system of equations, using the method of substitution. So let's write that right here in capitals. Substitution. Lots of T's in that word. 3, in fact. Okay, substitution. So the first goal of substitution would be to isolate a variable, or get one of the variables all by itself. So let's say isolate a variable. When we isolate something, it's all alone, right? Okay? The next step that we're going to do is plug in to the other equation. And I'm going to do other in all caps because it's important. If you plug into the same equation, you're not going to make any progress. To the other equation. The third step is to solve for the variable. And the fourth step is to plug your answer back into any of the equations, either of the equations I could say. Plug your answer back into either equation. And the fifth and final step is to solve for the remaining variable. Okay, I know right now this is just sort of a boring list of procedures, but as we do the problems, while they still may be boring to you, it will make sense what the steps are. Right now it's just kind of a bunch of words, I know. But as you see me do it, they'll start to make sense. Okay, step 1 says isolate a variable. I want to choose one of these 4 variables. I know there's only 2 different ones, but you can see them in 4 places, right? There are 2 x's and 2 y's. I want to choose the one that's going to be easiest to get all alone by itself. I think that is going to be this y right here. Because, as you can see, all I have to do is subtract 2x on both sides, and y will be isolated. Subtract 2x, and I subtract 2x, and I get that y is equal to 10 minus 2x. Good. Step 1 is complete. Now we plug into the other equation. What are we plugging in? The thing that we just solved for. So we will take this piece, because we know that y is the same as 10 minus 2x. That means where y is in the other equation, we can just replace it with 10 minus 2x. Remember, they're exactly the same thing. So now when I rewrite this equation down here, I will get that 3x minus 4 times y, but we know that y is now 10 minus 2x, that's where the plugging in comes, is equal to 26. Okay? Check. The next step is to solve for the variable. In this case, we have an equation with just an x in it. We know how to solve for x when there's only one variable. So I'll distribute my negative 4 to both places and rewrite this. Negative 40 and then a positive 8x is equal to 26. I combine like terms. 8x and 3x can go together, to give me 11x's minus 40 is equal to 26. Now I will add 40 to both sides to get that 11x is equal to 66. My final step here is to divide by 11 on both sides, and I find that x is equal to 6. Woohoo! We already have one of our answers. The goal, of course, is to solve for x and y. We have x's answer, so we can check that. We solved for the variable. The fourth step says to plug our answer back into either equation. Okay, let's choose the first equation. We can use either one. It doesn't matter. So that means I'm going to take 6, and I'm going to plug it back in to this first equation. In for x, of course. We know that 6 now is the same as x. So, when I rewrite this, I have 2. Now instead of x, I'm going to put 6 times 6 plus y is equal to 10. 2 times 6 is 12 plus y equals 10. Whoops, I forgot to do that check. We plugged our answer back in. Now we're on to the fifth step, is to solve for the remaining variable, which is y. Let's get it all alone. I subtract 12 on both sides, and I get that y is equal to 10 minus 12 is negative 2. So here now, my friends, we have our answers. X is equal to 6, and y is equal to negative 2. We could also write that as a coordinate point answer. And our coordinates, we always know that our x comes first, that will be 6, and our y comes second, that will be negative 2. Alright, we have finished this problem. We have solved for x and y and used substitution. And let's do that final check. I hope it helped.